Next, we discuss with the topic is called nature of matter. So, what is the nature of matter? Okay, you are already familiar with the term called matter in your previous classes. Okay, you have studied about the matter. What is the matter? Matter is nothing but anything which has a mass and it occupies a space. Okay, so what will be matter? So, everything around us that is called as matter, composed of matter. So, if you take this chalk, it is also one matter. Okay. So, living beings, book, pencil, etc. These are all composed of the matter. And matter, this is basically, it has a three physical status. Okay, you know that all of you, that is solid, liquid and gases. Okay. Solid, liquid and gas. Okay, so solid, you know that solid, the atoms are very tightly packed with each other. I mean, they are very closely packed with each other. How will be their atoms? Here, if I take one container, here the atoms will be very closely packed. I mean, there will be no gap between the two atoms. They are continuously and closely packed with each other in container. If you take the liquid, here what happens? Here some atoms will be there, will be little bit free will be there. Okay, little bit there will be free will be there. Whereas in the liquid, okay, what about the gas? In the gas, what happens? The atoms they move randomly. They will move randomly. Okay, this is the one properties. The difference between the solid and liquid gases. Okay, one more we can tell that. So it has a solid, it has a definite shape and volume, right? It has a definite shape and volume. If you take the book, how it is the book? Book is in the rectangular shape. Like this will be there. Definitely they have the shape and volume. Okay, they have shape and volume. What happens in the liquid? In the liquid, they have a definite volume but not shape. They have only volume but not shape. So if you take the water, okay, if you take the water, it has a volume but it doesn't have any shape. Okay, when you place the water in jug, in bucket, so that it acquires their surroundings. Okay, so that's why it has a only volume but not shape. So what about gas? It has neither shape nor volume. Okay, it doesn't have any shape and volume because they will be randomly moved. Okay, so about the third point of this properties, so that is called fluidity. It is called fluidity. What do you mean by fluidity? Fluidity is nothing but the substance. Any substance which have a tendency to move or flow. Other movement irregular. Fluidity and there will be some movement will be there. Okay. So here solids have no fluidity, but whereas liquid and gases have fluidity. Why? Because what happens in the solid? Due to the atoms, they are very tightly or closely packed with each other. They will be having the kinetic energy very less. Why? Because very less. Because there will be no movement at all in the atoms. Okay, that's why there is no kinetic energy. Hence, there is no fluidity. Come to here, liquids. Okay, liquids there will be free will be there. Atoms, their movement will be very little bit free will be there. So that has fluidity. But what about gas? Gases. It contains maximum kinetic energy due to the free movement of the particles, free movement of the atoms or molecules in all the direction. That is called free motion. That's why it has a fluidity, high fluidity compared to liquid and solid. Okay, come to the next one is compressible. So this is also one of the important property, compressible factor. But water here, the solid has no compressibility. Solid has no compressibility, whereas liquid is also no compressibility. But gas have compressible, highly compressible. Okay, if you take the water in the liquid, if you can compress here, no, you cannot compress it. So that's why it is no compressible. Whereas in gases you can compress. Okay, I can give one example that you know the cycle pump. Okay, when you compress the gas particles will be in the pump, there will be random movement will be there. When you apply some pressure, what happens? They come into close with each other. Then if you apply a still more pressure, then the gas particles will move into the water tube. So they will be having some compressible will be there. So these are the properties of solid, liquid and gas states. We have studied all the three physical states of the matter. So next we will see the interconvertible. How they are interconvertible with each other. That is solid, liquid, gas. Okay, let's see how they are interconvertible. Okay. So solid, it can be converted into liquid. It can be converted into liquid and liquid can be converted into gas. How? By upon heating. Okay, by upon heating. So this symbol is nothing but heating symbol. Okay, this symbol is nothing but heat. So when the solid it gets heat, it forms the liquid, and upon further heating of the liquid, it converts into gas. So these are the convertible. So now in the reverse order, what happens? So gas molecules, I am going to cool it. When you cool the gas molecules, it liquefies to liquid state, and further cooling, the liquid converted into solid. You can give the example for your ice cubes. It starts from ice cube, solid. So ice cubes will be in the solid state. When you heat, okay, when you heat that substance that is called ice, so it converts into liquid, and further heating this liquid, that is when the water boils, it starts to give the vapor. So vapor is nothing but gas. Okay, in the reverse process, that gas molecules can, when you are going to cool it, then it collects as a liquid. So upon further cooling, that is if you keep the water in the fridge, then what happens? It comes into solid, that is water converted into ice cubes. So these are the interconvertible. Till now we have discussed about the three physical states of the matter, that is solid, liquid and gas. Now we can classify the matter into two types, that is based on the macroscopic level. So what are those? The matter can be here classified as, one is pure substance, one is called pure substance, and another one is called mixtures. As the name indicates, mixture will be that is called, it is impure and this is the pure. The pure substance is made up of only one type of substances. I mean here there will be no mixing, that is pure. But here mixture is made up of two or more substances or components of different kinds, any proportions of the ratios. The ratios may be any different. If you take that 1 spoon of sugar, when you dissolve in 1 glass of water, so that will be different in the portion, the ratios. Okay, if you take 1 glass of water and you are going to add 1 spoon of the sugar, so that will be different kinds of the substance of any kind of ratios. Okay, here pure substance is where it is pure and this is impure. So again this pure substance can be classified into two types, that is called elements and compounds. Elements and compounds. So elements nothing but these are the simplest substance which is made up of one or more substances of same kind, only same kind. If I take one oxygen atom, so that is also react with one more atom of the oxygen only, because of the same kind. That is examples for elements is oxygen, hydrogen gas, nitrogen gas. Okay, when these substance of one atom which combine with another substance, I mean another substance is same kind of that atom, so that is called the elements. What about compounds? Compounds are made up of two or more substances of the different kinds of element. Like example, ammonia, water, carbon dioxide. So these are the example for the compounds. And here in the mixtures I am going to classify as two types again. First one is homogeneous. Homogeneous mixtures and heterogeneous mixture. Heterogeneous mixtures. So what are these homogeneous? As the name indicates, homo means same, hetero means different. Okay, homogeneous means same portions. Okay, if I am going to add two or more components, what happens of the same phase will be same. So suppose if I take sugar in water solution, what happens after some times, after that shaking, the sugar will dissolve in the water to make a one uniformity will be there, uniformity will be maintained at the composition. So that is called homogeneous. And example for this homogeneous is sugar when you add in the water, or if you add the salt in water, what happens after some times, after stirring, it comes to the one uniformity will be maintained. Whereas in the heterogeneous, different kinds of phase will be formed and there will be no uniformity. Example, if I mix sucrose, if I mix sugar and salt, what will be formed? That is called heterogeneous. The phase will be different. And if I take oil and water, okay, oil and water, what happens? There will be different phase will be there. So these are the classifications of the matters. Okay, thank you.